Hi everyone, so today I'm going to be presenting on my project topic, which was tuberculosis. Okay, so after this lesson, you guys, the students, will be able to identify what tuberculosis is and what causes it, how tuberculosis spreads, the signs and symptoms of it, where it originated, and progress that's being done in research. So when I say research, I mean research in effective vaccines for the different strains of it, research in more effective therapies for those who have it and the vulnerable who have it, such as those with compromised immune systems, and especially those with HIV and AIDS. So things like that, just a general sense of improvements being made towards better therapies for it. Okay, so what is tuberculosis? So to kind of give you guys a general overview of what it is an infectious bacterial disease, and I have a question at the top of this slide. Do you know what a cough aerosol is? So if you've been kind of, paying attention to everything with COVID-19 and the pandemic, you know that COVID spreads mainly by cough aerosols. When someone sneezes or coughs with COVID, they can spread it through the air. Well, that's kind of the same thing with tuberculosis. So when someone with tuberculosis, as you can see in this picture at the top, coughs or sneezes, the droplets from that can spread through the air to another person. The bacteria, though, normally attacks the lungs, but TB bacteria can strike any part of the body. So it can affect the kidney, the spine, the brain, and various other parts. It is a transmittable disease, communicated only by cough aerosol. Not every person infected with TB bacteria gets sick, though. There are two TB-related conditions that exist, latent TB and the general TB disease where someone gets sick. So latent TB is when someone has TB, but they are not showing any symptoms, and they have a normal chest x-ray when they are diagnosed. So basically, it's just kind of lying, as I said, dormant in their body. They are kind of like asymptomatic COVID-19 patients where they're not feeling sick, but they're testing positive for TB. Okay. So where did it originate? TB in humans can be traced back to Atlat Yam off the coast of Israel about 9,000 years ago. In the 16 to 1800s in Europe, TB was causing 25% of all the deaths during this. The discovery of the bacteria that causes tuberculosis was confirmed by Dr. Robert Koch on March 24th, 1882, and this is a picture of him on the side that I have put for you guys. During this time, going back to the United States and still staying in Europe, TB was killing 1 in every 7 people living in these areas. So it was very prevalent. It was a common disease at the time, and it was kind of associated with being kind of like a plague-like disease. So I also have a question for you guys on top of his picture. Why do you think that diseases like TB that have originated so long ago are still being treated today? Okay, so how does TB exactly spread? We kind of talked about how it spreads through the cough aerosols and sneezing, but I want to go into it a little bit more to have you guys understand. So TB bacteria are transferred from one person to another through the air. TB bacteria are released into the air, as I said, when a person with lung or throat tuberculosis coughs. But this is how TB does not spread. It doesn't spread by shaking someone's hand. It does not spread by sharing food or drink, touching bed linens or toilet seats, sharing toothbrushes, or kissing. So saliva does not spread this. It has to be spread by cough aerosols. And TB disease may be contagious in the lungs or the mouth. Okay, going in more depth about the signs and symptoms of TB. On the side, I have a kind of a picture, I wouldn't say it's a diagram, of the main symptoms of pulmonary tuberculosis. in the body. So in the central nervous system, in the lungs, and in the skin especially. If anyone were to have latent TB, the bacteria would live in an inert state in their body and you wouldn't show any symptoms, as you know. If someone were to have an active TB infection, though, some of the signs and symptoms would include coughing that lasts 3 or more weeks, coughing up blood especially. It's kind of like a deep hack, I would say, and it doesn't go away. It's prolonged. There's chest pain or pain when you breathe or cough, unintentional weight loss, fatigue, fever, night sweats, chills, and loss of appetite. So to go over this again, kind of just at the top in the bubble, if someone has latent TB, are they contagious? And the answer is no, they are not. So you can have 2 types of TB. You can have one where you are contagious and spreading the illness, and then you can have another one where it is just lying dormant in your body and you are not showing any symptoms. Okay, so who is at risk? TB disease can occur in children at any age. So the people who are most at risk are children because they have vulnerable immune systems, and those who are HIV positive and who have AIDS because they have very vulnerable immune systems and compromised health. Pulmonary TB, though, is the most prevalent form in infants. And those who are malnourished, who are living in the house with someone who's infected with TB, they're more likely to become sick from that and die if they have these pre-existing conditions. So a question for you guys is, why might children in underdeveloped countries be at more of a risk for TB than children in developed countries? Kind of to give my own thought on that, what I would say, because when we learned in the semester in our book, underdeveloped countries, they are lacking clean water, hygienic practices that are obviously good. It kind of puts everyone at a more of a larger of a risk because things can't be as clean as they should be. But I want to hear what you guys think. What are your thoughts on that? Okay, so what is the treatment for TB? Good news is the condition of TB is curable, because I feel like this presentation's kind of been on the doom and gloom side of TB, but those who have TB would have a typical treatment of 4 antibiotics for 6 months. It does not respond to antibiotics often. You could have a resistant bacteria strain, and this suggests that recovery would take longer and it could become complicated. This is probably why tuberculosis is still a prevalent disease. In the case of TB infection, where someone might be infected but doesn't become sick, latent TB, as we call it, preventative care can be prescribed to avoid the onset of the disease. So it's kind of just like a waiting period to make sure that the person who has latent TB doesn't get sick and doesn't infect others that they are either living with or coming into contact with. Between 2000 and 2019, researchers have saved an estimated 58 million lives through TB diagnosis and treatment. So kind of at the top as a reminder, tuberculosis can be antibiotic resistant, especially when those diagnosed with TB do not finish their antibiotic treatment. Because, there are bad side effects to antibiotics, but they kind of have to push through that and finish it because it is there to help them. Okay, and then here's a video about what makes TB the world's most infectious killer.
In 2008, archaeologists uncovered 2 9,000-year-old skeletons. There's no definitive way of knowing what killed these ancient people, but we do know their bones were infected by an all-too-familiar bacterium. The ancient Greeks knew its consumptive effects as phthisis. The Incans called it chaki-onke, and the English called it tuberculosis. Today, tuberculosis, or TB, is still one of the world's biggest infectious killers, causing more deaths than malaria or even HIV and AIDS. But what exactly is this disease, and how has this pathogen persisted for so long? Typically, TB bacteria, called Mycobacterium tuberculosis, are airborne. They travel into our airways and infect our lungs. Here, immune cells called macrophages rush to the infection site, attempting to absorb and break down the bacterial invaders. In many cases, this response is enough to remove the bacteria, but in individuals with other medical conditions, ranging from malnutrition and HIV to diabetes and pregnancy, the immune response may not be strong enough to destroy the intruder. If so, Mycobacterium tuberculosis will reproduce inside those macrophages and form colonies in the surrounding lung tissue. As they infect more cells, the bacteria employ cell-degrading enzymes that destroy the infected tissue, triggering chest pain and causing patients to cough up blood. The damage to the lungs leads to oxygen deprivation. This begins a flood of hormonal changes, including a decrease in appetite and iron production. From here, microbes can spread to the skeletal system, causing back pain and difficulty moving, to the kidneys and intestines causing abdominal pain, and to the brain, causing headaches and even impaired consciousness. These symptoms produce the classic image of TB: weight loss, a hacking bloody cough, and ashen skin. This ghostly appearance earned TB the title of the White Plague in Victorian-era England. During this period, tuberculosis was considered a romantic disease because it tended to affect poverty-stricken artists and poets, those with weaker immune systems. TB's outward symptoms even helped fuel the popular myth of vampirism. In spite of, or perhaps because of, these less than scientific concerns, this period also marked the first strides toward curing TB. In 1882, the German physician Robert Koch identified the disease's bacterial origins. 13 years later, physicist Wilhelm Röntgen discovered the X-ray, enabling physicians to diagnose and track its progression through the body. These techniques allowed researchers to develop reliable and effective vaccines, first for smallpox and again in 1921, when scientists developed the BCG vaccine to battle TB. These developments laid the groundwork for the modern field of antibiotics, currently home to our most effective TB treatments. But antibiotics fail to address a major diagnostic complication. About 90% of people infected with TB don't show any symptoms. In these latent infections, the TB bacterium may be dormant, only activating when someone's immune system is too weak to mount a defense. This makes TB much harder to diagnose, and even when properly identified, traditional treatments can take up to 9 months, requiring multiple drugs and a high potential for side effects. This discourages people from finishing the full course, and partial treatment enables bacteria to develop resistance to these drugs. Today, the disease is still prevalent in 30 countries, most of which face other health crises that exacerbate TB and trigger latent cases. Worse still, accessing treatment can be difficult in many of these countries, and the stigma towards TB can discourage people from getting the help they need. Health experts agree we need to develop better diagnostics, faster-acting antibiotics, and more effective vaccines. Researchers have already developed a urine test that yields results in 12 hours, as well as a new oral treatment that could cut treatment time by 75%. Hopefully, with advancements like these, we'll finally be able to make TB exclusively a thing of the past.
Okay, so just gonna exit out of this. So after watching that video, it kind of gives more, I'm just gonna hit this, okay, cool, to make it a full screen again. It kind of gives more of an overview of TB and the history and kind of the superstitions around it. People believed it to be the White Plague and that those who had it were vampires because of how pale their skin was and because they were coughing up blood. So back then, there were a lot of misconceptions about the disease. It spread fear and panic, and people didn't understand it. So kind of a little bit like now, you know, if you can think back to like March, April, we didn't really know what this was, and there was a lot of mass fear and misconstrued facts about COVID-19. Okay. So I want to go back into TB and HIV and more about that. Tuberculosis, especially for people living with HIV, it is a significant health threat. TB is among the leading causes of death for people who are HIV positive. HIV and TB may combine to shorten survival without treatment because of how someone with HIV, how compromised their immune systems can become. So for patients diagnosed with HIV who already have a latent TB infection or a TB illness, there are a variety of treatment alternatives. So vaccination might be the most successful means of fighting the two diseases. The new TB vaccine, BCG, it doesn't fully eliminate pulmonary TB in adults, which is the most common type of the disease, in adults also. And as we all know, there's no reliable vaccine against HIV. There is no cure. So it is a difficult thing, the two of them, to treat. The WHO, the World Health Organization, recommends preventative treatment for people living with HIV and all the contacts in that person's household who, if they are diagnosed with TB, and in order to prevent themselves from getting it so they do not spread it to the vulnerable. Okay, so I kind of felt like I wanted to learn more about debunking the myths of TB and to show it to you guys, because just with any illness, any disease, there are myths about it, and there are things that, you know, kind of get lost in translation. So the first myth is that tuberculosis is genetic, and I couldn't believe when I was researching that people believe this. It is transmitted through the air by bacteria when anyone with TB coughs. That is how it is spread. If your parents have TB before you're born, it doesn't mean that when you're born, you're more susceptible to TB. It's not going to be passed down to you. You can still get it, but that's not how you're going to get it. Myth, it can't be cured. A lot of people think when they have TB, it is a death sentence. It is not if you have a healthy immune system and not really any pre-existing conditions. If you have a non-resistant strain of TB, modern medicine and antibiotics work sufficiently to treat it and cure it. Myth, TB patients can easily spread infection. There are numerous forms of TB. Not all of them are contagious, like the latent form of it. So, that is that. Myth, you can only be infected once. People who have been cured can be infected with TB again. It doesn't necessarily give you antibodies against getting it again. Your body is still susceptible to getting infected with it. After you've been cured, you can still get sick with it. Okay. Will there ever be an effective vaccine for every form of TB? So the prevalence of TB, particularly the common drug-resistant diseases, it kind of demands increased attempts to create a fast and sustainable vaccine. There have been promising candidate vaccines that are already present at different stages of clinical research, but it still remains the second leading cause of infectious disease death worldwide, despite having a 45% decline in the mortality rate and a 41% reduction in the incidence rate between 1900 and 2013. But recent advancements in the delivery of DNA vaccine techniques have renewed interest in creating a safe and efficient TB DNA vaccine. So there is hope. It's still causing infections worldwide, but we are working towards having better and effective treatment. So the progress being made in research exactly. In terms of biomedical research, 2019 was a substantial year of development in supporting this global campaign to end tuberculosis. There were some possible therapeutic drugs that could be available soon. As I learned in the article listed below, 2019 a banner year for tuberculosis research. The journey to a vaccine for tuberculosis has strengthened with recent infection numbers growing over the years. What's most important about this, though, is that we need fast, reliable, affordable diagnostics, especially for underdeveloped countries. That is the only way we're going to be able to combat this effectively. And we need a commitment that is collaborative in order to achieve this objective of ending tuberculosis. So I kind of wanted to include someone famous and well-known who has had TB, and I was shocked to find out that Eleanor Roosevelt had it, and she actually died of this in 1962. So if you don't know what Eleanor Roosevelt is, she was the former First Lady of the United States during her husband FDR's presidency. And when she died in 1962, kind of one of the main causes of her deaths was that the doctors were perplexed that she had not responded to a 6-week treatment. She kind of was struggling and battling with this resistant strain. It is also likely that her infection was a major drug-resistant TB that was circulating around in the early 1960s and the strain that we see now today. Her death from this is a cautionary tale about how we can have antibiotic-resistant strains of diseases, and it kind of just serves to incite more research about how we can combat this. And that is a picture of her on the side. So I also just kind of wanted to include a timeline of when, going back to TB's discovery, all the way up until 2015, about the different drug-resistant strains and the numbers of infections, and how much these numbers of resistant strains have gone up and have become untreatable. So I'll let you guys look at that for a few seconds. Okay. So to end this, I have some discussion questions for you guys. So prior to learning about TB, how did you think it spread? Do you think that there are many common misconceptions with illnesses like TB that are associated with HIV? What can you do to prevent yourself from getting TB? With other deadly diseases becoming globally prevalent, such as COVID-19, do you think that research should continue in order to find an effective vaccine for TB? I'll pause for a few seconds so you guys can see those.